So the first token where we are going to read of the overall procedure, read this input file, this entire input file, parse them as tokens. Okay, so parse them as tokens is the tokens showing right here. That's the actual input, not necessarily this, but this will be more visually guidance for you. So what is exactly the thing we're talking about? Otherwise, if we're just looking at the tokens, it's just kind of confusing. All right. So the first thing we're going to do is here. And of course, we are going to have our symbol table being presented right here. Currently is empty, nothing really there. And of course, we're also going to have some kind of levels as global variable. Currently, for my implementations, I will initialize it as -1. You will see why I'm initialized as -1. People having different implementation, sharing different implementation. You could have a 0, you could have -1, you could have -2. That is your implementation, not necessarily mine. I'm talking about my implementation. Okay, so my implementation is -1. Okay, any other things we need to talk about in the global sense? I think that will be it. Okay, level, symbol table, and code list actually here presented on here. Simply you just consider it's empty right now. Okay. Now the first token is var, of course, but whenever we get into the grammar itself, we actually calling the program as a function. And this function, grammar, is calling another function calling block, right? In the block, actually, whenever I get into a brand new block, or just literally get step by step into the block, my level raised up. Therefore, +1 now is 0. So I'm properly step into a level of 0. That is actually my starting point. Okay, so 0 means I'm currently in the global sense. All right. Now we are checking constant declarations. It's the first thing we're going to check. Constant declarations, and we are getting here. We check, is this constant declaration? No, actually we have var. Why should we do the constant declarations? So doesn't match. Getting back to here. Next one. Variable declaration. Okay, now variable declaration it is. Go check variable declaration. And we are checking var. But are we missing something? Actually, before the block, before the checking the constant declaration, variable declarations, I've said whenever you're getting into the block or getting into the program, you are generating instruction. In homework 3 is generating what? Yes. 703, jump 03. But now we are generating a JMP 0 unknown. Okay, for this unknown. We're getting to the block. We're generating something. But this something is or unknown. We'll simply record is, let's say, CX. CX is currently equal to 0. Okay, good. Now, next to the variable declaration, we're simply jumping back to our variable declarations to check. Is a variable declaration? It's variable. Good. All right. Now we are proceeding to the next part. And next part is A, identifier. A is identifier. And what you are going to do is going to check the symbol table. Check everything. A is being declared before, checking from the bottom to the top. Declared before? No, never been declared before. Is A having a different level? No, there's not a, even included in the symbol table. So not being declared before, not being checked, not being in different levels, not being in a marked of 1. Okay, so it means we can safely insert the symbol into our symbol table with type of 2, level, 0, value, 0, address, mark. Okay, so why 3? It is related to your homework 1. Why is 3? It related to homework 1, activation record. Okay, don't get confused. 3. Yes. Jump 018. Okay, go ahead. That's the thing we are going to resolve today. Okay. Now, later of this procedure, we have not known this modifier's actual value yet, but we will eventually know that. But when do we know that? That's the thing we're going to talk about. Don't worry. Be patient. Okay. Be patient. Now, identifier. Next symbol. Next symbol, comma. Comma is comma. Check. No problem. Identifier. Identifier is B. B is declared before. Is different level sharing, different level sharing same name? Unfortunately not, because we're in level 0. Is it being marked? Anything being marked as B right here? Unfortunately not. So we can safely insert this symbol into our symbol table. B type is 2, level 0, value 0, address 4, mark 0. Initially, everything is 0. Okay. Now, semicolon. So basically, we're not getting to the loop again and simply checking is the different. Okay, we're checking here. Semicolon is semicolon. So checking, check. And we are getting back to here, actually. And we're going to continue our procedure declaration. Now, simply getting rid of those things to not confuse you. Okay. Check this. Procedure. All right. Simply we're going to the procedure. So procedure declaration it is. We're checking. Oh, we have curly bracket. Curly bracket means what? Implementation wise, does it mean? 0 or more time, that's conceptual how you implement in real life. You have said 0 or more times. If statement only matching 0 or 1 time, then what's correct? Whenever you see a curly bracket, it means you are implementing everything in a while loop rather than some kind of if loop. All right. So while loop, we are checking procedure. Procedure, it is a procedure. So that's a keyword, reserved word. And next thing you're going to check is identifier. Okay. Identifier, that's X. X is identifier. And we are going to search from the bottom to the top. Is X identifier be declared before? No, we didn't find it. So can we safely insert that? Yes, we can. And we don't find any duplicate in the sense in the symbol table. So we can safely insert that. X, let's say 3. Okay. Level 0, value 0, because we simply don't consider its value for constant or variables and procedures. So level 0. Address. Let's talk about it. address is for this one is kind of confusing. Now, before we get into the procedure declarations, or actually the next thing about the procedure declarations, whenever we insert that additional things or instructions, we will be always starting with, because your current CX is pointing to this empty slots, empty, so haven't generating anything. But we know whenever we get into a procedure, the first instruction we are going to generate for that procedure will be the jump instruction, right? That jump instruction will be definitely insert in that position, index 1, correct? Index 1, so when is being generated? Whenever we get into the block. Now we know this CX currently pointing to that instruction is 1 right now, will be our starting point of procedure. Even though the modifier, the jump instruction still leads up to a fake address for now. But we know it eventually it will be resolved. Therefore, we can use the jump instruction as our indicator of our procedure's beginning, starting point. That's the most important thing you need to remember. Therefore, in this symbol table insertions, we're simply going to insert CX 1 times 3. Therefore, 3 Markov 0. Remember that. So that is the procedure we are going to insert. Okay, now, next part. We haven't generated this, still empty right now. Next, semicolon. Semicolon it is, so no problem, check that. And a block, getting to a brand new block. It means there's a lot of things going to be changed. First, level. Changing to +1. It's 1 right now. Whenever getting into a new block, level raised up. Okay? So block a brand new things. And inside this first block, we are going to generate JMP 0 bogus, fake address. Okay? That's the first thing we're going to generate. And our CX is currently pointing to 2 right now, not 1 anymore. Okay? Any question? Any question for that? Okay, great. So again, level is 1 right now. So let me clean up a little bit. Level is 1. All right. So we are going to get constant declarations. Do we have constant declarations? Unfortunately not. Variable declarations, variable declaration is, and we check var checked, identifier. Now, the most interesting thing coming up. Q, is Q being declared before? No, we can safely insert that. And W is never being declared before. We can safely insert. But coming different scenarios, how about this? We're going to use var A and B to completely replacing the variable Q and W. Then what happens? Can we safely insert that? Why not? Same variable and because they're sharing the same variable is becoming a same. Is that right? Learn from mistakes. Even though you are making some mistakes, just say that you're understanding now. So probably most of you as having the same concerns. Why you think is cannot be inserted? Okay, that is your interpretation. Yes. How about yours? It's, yes. So they are considering a different aspect. Incorporating more aspect means they are in a different levels because we are currently in level of 1. Then it means we can actually insert A and B into the symbol table. Simply, they are in different levels. Okay, now you have the mistake being fixed. Now you understand this more. Okay, just use A and B for now. A can be inserted. 2 is a type, but is in different level. 1, value 0. Now, what is the address? Come on. Yes? 3? Why 3? What's that? On the current activation record, can we have a better word for that? Yes? Yes, offset. Of course, it is offset, but why we having 3? Yes. Then I should have phrased this question one more. Previously, we have 3 and 4 being recorded. Why it is now 3 instead of 5? Yes. Right. Whenever we raise our level, it means we are getting a brand new activation record. So brand new activation record means we are resetting our offset back to 3. That is why we have 3. Mark 0, and we have in brand new B 21040. Okay, so that is our intuition now being clearly split out. All right. But let's coming back to the QNW. So that is the thing we're following. But I'm going to add some difficulties upon that and how I modified how it's being clear before, clear everything. Okay. So we know variable A and B can be inserted safely, but we're coming back to QNW. Now QNW. Q never been inserted before, so it's 2, level 1, 0, value 3, 0. W 2, 1, 0, 4, 0. All right. Okay. Now, so basically we are getting to this bit, that semicolon. We are checking the semicolon. It is there. Check that, and we are finishing our variable declaration. Now we're getting proceed to the next one, procedure declaration. Do we have extra procedure declarations here? Do we have procedures? Reserve word? Unfortunately not, or fortunately yet, fortunately no. So we don't have to proceed, process extra stuff. So procedure, no. So simply get rid of that. And we are landing right here. Okay, just at the very end of the procedure declaration. Simply, we are not processing anything. Wait. What is happening? Okay. Now we are getting to the next variable. Next token will be the begin symbol. But here, is there something happening? Is there something happening here? Before we get into the statement, yes. That's the thing we're going to fixing. But why we are fixing that? Simply, we have all the necessary information to finishing up our activation record. And finishing up our activation record will be the inc instructions. Inc 05, why 05? Inc is what we are generating in this position. 0, nothing special, still level of ink will always having the 0, level of 0. 3 plus 2 is 5. But why plus 2? Simply 2 local variables. Okay, so ink 0, 5. But now it is pointing to index 2. Okay, index 2 means we have something about updating the CX equal to 1. So you are going to access the code using the CX and dot M equal to 2 times 3, which is 6. Let's check that out. 6. Okay. Now this jumping instruction is correctly leading to the ink. We actually fixing that fake. Did I answer your question, your concern? Is that fake address even necessary? It is necessary. Now you know why we're using the fake address. Now, how we resolve the fake address is now being very cleared. If you do have other questions, please read them. Anything? Anything? No? Great. All right. So next thing about statement. Now we insert this one. Statement is the one we are going to proceed. Let's get rid of it. Okay, statement. Inside statement, we know is a huge chunk of if statement, switch statement, whichever you prefer. The current token is begin. It means we are going to execute this part. All right, begin. Begin statement, and we are going to simply check that. And now next token is Q. Q is identifier. We are simply getting to the statement, which simply recursively calling the statement and check Q is what? Is identifier, right? So this is the line we are executing. Identifier, it is identifier. But before we use this identifier, we're going to simply check whether this identifier been declared before. Okay? So what you are going to do is search from the bottom to the top, find Q. Okay, when you find a Q, Q's type must be 2. It must be a variable. Otherwise, it just doesn't make sense. Sign into a constant? No, no. Sign to a procedure? No, no. So sign up to the variable. So it's happy to. That's the first thing you are going to check. Next thing is about levels. My level currently is 1. 1 is equal to 1. Is of course, you have to check that. But how about this one? This Q dot L has to smaller or equal to the current level. That's the actual condition we are going to check. And it means, what if I'm going to use QA equal to 1? A can be accessed right here. Its level is 0. 0 is smaller or equal to the current level. It's holding true. It means we can use it. Okay? Then the last bit you are going to check is the Q's condition. Q's mark is a mark of 1. Is 0. It means it is usable. You have to check that. It is usable. So 3 conditions holds true means we can safely use it. We can safely proceed to the next. Proceed to the next semicolon. Oh, not semicolon, become symbol. Become symbol is become symbol, no problem. Next one, expression. We're calling expression. Expression here. All right. So expression, and we are going to call terms. Okay, that's the next thing we're calling. But before that, have to make sure that everybody is on the same page. how many of you have written some kind of like while checking plus or minus symbol before calling the term? What's that? Somebody is raising up. Then you are wrong. Yep, it is a wrong implementations, as this current grammar does not support any negative numbers. Okay? Does not support negative numbers. Whenever you do the checking, it means you are checking the expression. The first item is going to be positive number or negative number, which is incorrect. Okay? So get rid of the while loop or if statement in before the checking or before invoking the term. Okay. So that's the thing we're going to talk about here. Now, next one, factor. Factor it is, and current token is 1. Okay, it is 1. 1 is a number, right? So inside number, we are simply going to generate an instruction, which is LIT. Lit a literal 0. What is number? 1. So is it? All right. We're generating instruction. Now we're getting to generating safely, correctly, and heading back to whoever called us. Do we have plus multiply symbol or divide symbol? So just skip this part and getting back to here. Plus symbol, minus symbol. Current token is semicolon. So do I have that? No. So getting back to here. Okay, just recursive back to whoever called us. Now we are basically finishing this assignment statement processing and heading back to here. And we are going to check, is the current token is semicolon? Actually is. It actually is. Consume that. Consume that. And we are going to proceed to the next. Okay, and the end token is the current one holding. Let me get rid of this part. Okay. Okay, so we are getting to this statement, and we are checking from the top to the bottom to check, do we have anything related to end? So it means something with empty statement, a jumping name. So simply we do not proceed, to not consume anything, simply getting back to whoever called us in the statement, simply getting back to here, and current token is end, means we cannot do the looping anymore. Getting to the next one. End symbol is end symbol, holding true. So consume that, proceed to the next token. Proceed. Then here we are getting back to the statement again. All right. Getting back to the statement, and here is the last bit. We are exiting the block. Exiting block 2 here. But before we exiting, there's a couple different things we are going to do. Level minus minus. Whenever we're getting out of a block, level will be decremented. It will be 0. It is 0 means whatever the variables, symbols being inserted into the symbol table with that that scope will be having a mark of 1. Okay? Any question for that? Yes. So anything that was in the... But do we need to mark of X? Do we need to mark this one? The question is. No. Why? Simply procedure's symbol is in level of 0. It is not in level of 1. Okay? All right. So it means you are going to do something with marking with some kind of while loop. While loop is checking if the level is equal to 1 and you are going to mark it. All right? Yeah. Exit block, not necessarily the procedure. Exit block. Okay. Now, getting to the next part, and oh, he's getting confused. Let me get rid of something. All right. So here, we're actually having a store being generated. Store is for this one. Store 03, store, okay. That's the thing we are going to talk about. So before we actually jumping out of the block, actually, the current level is 1. Okay. We are still in here. Just zoom back, step back a little bit, reverse some steps. And we have everything right here is 0 and 0, 0. All right. 0 and 0. And we are going to do generating the store instruction. So simply we have this identifier being inserted, and we are going to generate store level here. Level is important. We are going to do is L minus Q dot L. It means the current level is 1. Q dot L is 1. 0. Q dot address will be 3. Therefore, generating store 03. It's kind of confusing, but let me using a different example for you to understand. What if I have A? A equal to 1. We have done everything about letting and everything. We have checked A is legitimate. And what we are going to do? Still using the same pseudocode. STO level minus A dot level. Level, current level is 1. A dot level is what? 0. It means 1. And modifier. What is M? We're talking about A. A dot address is 3. Okay. So Y1, Y0. Fundamentally, Y1, Y0, Y0 for the Q, Y1 for the A. Yes. Correct. Correct. So Q, it means we are accessing the variable or variable in the current level. Current level is 1, and we are accessing relatively in the instructions. Current activation record, it means 0. Whenever we're accessing the previous activation records variables, it will be 1. So relatively speaking, level minus whatever the level before that will be level minus the symbol dot level. Okay. Now we have this instruction being generated correctly. And we are getting back to here the statement, and we are getting back to the end and jumping back to here. Actually, not here. It's jumping back to right here. Okay, jumping back to here, and we are simply it is a block, and we are going to exit in block while we are decrement our level, marking everything inside this level to be 1, And we are going to generate OPR00. That is for the procedure return. That is also for the activation record return back to the previous environment. Now we're properly getting to the procedure name or the global environment activation records. That is why we have generated OPR00. Next things about here is what we have finished this statement and we get into the block and we are checking the last bit is semicolon it is. So we simply check that. Okay, simply check that and we consume to the next is a begin symbol. And we are finishing up our procedure declarations, simply getting back to the previous one. Now it is the time that we are going to generate inc 0, 3 plus how many? 2. Now inc 05. We have this instruction is being generated as index 6. It means we now finally have the information to fix up the JMP instruction. So getting back to 6 times 3 is 18. Update that. Do we have the information? 18 it is. Now we have the fake address being fixed. Okay, so next thing is about processing the statement. All right? Yes. What's up? Whenever you're generating inc instructions, it means it is your time to fix the JMP instruction. JMP instructions, fake address. Yeah. Whenever you generate firstly generating the JMP instruction, it will be having a fake address. Yeah. Mm-hmm. I just want to show why it was 8. When is it becoming 18? When it's becoming 18. When it's becoming 18, because this having the inc in the same level, this JMP is generating right here, right? This inc address, inc instruction is generating here. They are in the same scope. Okay, so how about this? Whenever we're getting to the procedure having the block initiated, so it is basically generating a pair, JMP and inc. Is that right? Come on. Is that right? Oh yeah, it is generating a pair, JMP with the fake address, inc with the actual address in a call list, right? What is the JMP, the inc address, the index is 2, right? 2 times 3, 6. Is that coincident? Right? Then inside this block, and simply we have generate a pair, JMP and inc. Inc address index is 6. 6 times 3, 18. Is that coincidence? No. So it is basically generating a pair using the second pair's code index to coming back to update the fake address. Question? Yes. Mm-hmm. Here. Then you were simply generating another JMP with 0 or some kind of fake address, and you have inc something that is index, and you are going to use that to generate, so CX times 3. It doesn't really care. Yeah. Because they are in different levels, of course. Okay. Now, everything clear? Question? Seems to be confused. What? All right. So now let's proceed. We have the ink being generated. Ink address being generated. Next thing we're going to proceed is statement. Inside statement, this is the one we are going to generate. We're going to invoke begin. Begin is begin. Check that. All right. Next thing, statement, identifier. Still following the same procedure, checking the identifier is being used before or is being declared before, is usable or not. So A is usable and is type of 2 and mark of 0. Of course, therefore we can proceed. Okay, but what we are going to do is exactly following the same procedure is like what do we have here, the become symbol, the expression, the term, the factor, and to load everything, that'll be lit 02. That is for this number. Okay. But now I'm having a different question for you. So what if I'm getting Q is equal to 2 instead of A equal to 2? Yes. Right. So what you are going to do is basically checking two things. Whenever you're using a variables, you're going to check Q is being declared before. Actually, in this symbol table, from top to the bottom to the top, is being declared before. You can't find a Q inside the symbol table. But the true thing is about the level. The level is the Q is 1, but our current level is 0. It means this one is greater than my current level. Simply, I cannot use it. That's first the condition you are conditioned. The second condition, the most important condition, is the mark. The mark is 1. It means it is no longer usable. So why can't I use it? So if it's 1, it simply means never been declared before. Error. Q is never been declared before. That's the only thing you are going to produce. All right? So here, that's the different scenarios. But once we're coming back to here is 2, and we lit to 2, and we are checking. This is going to generate store level L minus A dot level. 0 minus 0 is 0. And what is A dot address? 3. Okay? So store 0, 3. And next instruction is semicolon, semicolon, consume that. And statement, this call instruction. X, is it been declared before? It is. And we can find it. Its type is a procedure. Its level 0. It means we can generate a call current level minus X dot level 0. 0 minus 0 is 0. Address X dot address 3. Therefore, call 03. Get it? Question? And last bit we are going to do is to simply getting rid of everything here, and we are simply check. Okay, once we coming back to the call, and we'll check anything going to be furthermore, semicolon, semicolon it is, simply loop, but we don't have everything. Again, end is end, we have empty, checking the end, consume that, and getting back to statement. And here, in here, we are getting out of this block back to the program. It means level minus for my implementation is -1 right now. And I have to mark everything inside here to be negative. Oh, not 1, it's 1, 1, 1, 1. Everything here is 1. Okay, good. period symbol, check. Everything runs smoothly, generating whole instructions. Any questions? Yes. So that's the thing. So that will be the situation is I'm missing the semicolon right here. Okay. Yes, but the last semicolon, we can have this semicolon or not. It's still the same. Simply, we have this being checked or it never getting to the loop, directly go to the end. All right. Any other questions? So that's it for today's lecture. And we do have Richard and Ife is here. No? Nobody? I should have my TA coming up to have this UCF here to practice on that. So whoever is attending on the Zoom, thank you for coming.